In this video, we want to show that flat ring homomorphisms preserve non-zero divisors. So let us suppose that phi is a flat ring homomorphism between ring A and B. This just means that under the map phi, B can be viewed as a flat module over A. And let us suppose that alpha is some non-zero element in A that is not a zero divisor. We claim that phi alpha is also not gonna be a zero divisor in B. So let's see why that is. To use the condition of flatness, let us recharacterize what it means for an element alpha to be a non-zero divisor in A. Observe that alpha is not a zero divisor in A if and only if the only element that multiply with alpha to 0 is 0. In other words, the kernel of the multiplication by alpha map must be 0. So alpha is not a zero divisor if and only if the multiplication by alpha map is injective. Now, since B is a flat A module, tensoring with B should preserve injectivity, and thus this map, which was induced from this multiplication by alpha map, must also be injective. But this tensor product, these are just B. And under that identification, this map is just multiplication by phi of alpha. Indeed, observe what this multiplication does to a simple tensor. It maps the tensor A tensor B to alpha A tensor with B. Now, under the identification of this tensor product with B, we see that this simple tensor just corresponds to phi A multiplied with B, and this simple tensor corresponds to phi alpha multiplied with phi A multiplied with B. So we see that this map here corresponds to multiplication by phi alpha. Now, since multiplication by phi alpha is injective by our criterion here, we see that phi alpha is not a zero divisor in B. Thus we see that flat morphism preserves non-zero divisors.